Okay, afterward, the process we using the phosphorus in the bottom and the top superficial layer after we elevate the temperature. So the dopant on these two layers will be diffused into the polysilicon layer, poly 1 layer. Okay, and after that we still need to take out the top, hot PSG hot mask. Then do the patterning of the first polysilicon layer. So remember, we have a dimple structure before on the first superficial layer. So after we deposit the first polysilicon layer, some material will be deposited into this two hole region. Okay. So you can imagine, after I take out the bottom superficial layer, so this structure will descend and come to contact with the bottom surface with only these two dimple area. So that means the contact area will be greatly reduced. Originally, you have the whole surface contact with the bottom. Now I have two dimple on the bottom, so the structure will be stand out. Okay. So only two small area will contact with the bottom surface. That will reduce the friction. 会减少摩擦，因为现在只有两个 dimple 的区域接触到表面。OK， 在结构释放掉以后。Okay, so it's easy to understand. Okay, so there's different things to the CMOS process. In CMOS process, we don't have a dimple structure, so that's why you need to specially design a structure for that purpose. But in this MUMPS process, we already have this kind of design inside the mask structure, so you can use that freely. So this we talk about. Okay, for the dimple structure, you already RIE patent the number 3 masking for the first oxide layer, and number 1. Okay, so you have a number 2 for the dimple, number 3 for the oxide, first oxide layer definition, and then you have a max number 4. Okay, for the first oxide. First polysilicon layer. Okay. So after the first polysilicon layer deposition and the patterning, then you can deposit the second superficial layer to isolate the first poly to the second poly. Okay. So and then we pattern the second superficial layer, then deposit. Actually, we need to notice in the second superficial layer patterning, we have two different commands. One command is related to, we only define, pattern the thin superficial layer, the second superficial layer. So this process we call the thin, okay? Thin layer etching. We don't etch in thick layer. However, in some other case, we want to contact the second poly to the bottom surface, bottom structure. So in this case, if you only puncture holes on the second superficial layer, this is not thick enough. So in this case, we need to have a second command we call the thick layer etching process. The thick layer etching process can punch through not only the second layer of the superficial layer, but also the first superficial layer together. So you are able to contact from the second layer down to the bottom surface. After you apply the thick, the command of thick layer etching process. Remember, there are two etching processes here. One is a thin layer process etching. The other is thick layer etching. Thin layer is for only cutting through the second superficial layer, but the thick command will cut through the second plus the first one together. So you got an overall connection from the very top to the very bottom, okay, for the thick layer. So, and after that, you can deposit the second polysilicon layer, the structural layer. So in the center part, as you can see, we have already applied the thick command here. So we have the hole all the way down to the bottom. So you can see the center part, we have the second polysilicon can be used to connect to the bottom poly0 substrate surface. But for the other area, we only cut through the second superficial layer. So we can make the connection between the second poly with the first poly. So in the center, we can contact the second poly to the poly0. On the border, you can contact the poly2 to poly1. Okay, poly2 to poly1. So it depends on you apply the thin command or thick command at the side or at the center. Okay. So as before, after deposit the second polysilicon, we still need to dope the polysilicon with the phosphorus. So we deposit another hard PSG mask on the top, and the bottom we have a thin PSG layer as well. So after a kneading process, the phosphorus will be diffused from the top bottom and the top PSG layer diffused into the second polysilicon layer. Okay. Okay. So after this deposition, now you are ready to do the final etching process for the second polysilicon layer. So this is a number 7 mask. So now you can see this structure is exactly one of the example of our electrostatic motor. Okay, so when we remember back to our second or third homeworks, right? So before the homework, we demonstrated one fabrication process for electrostatic motor is a easier version, but in your homework, you design the second one is a more difficult one, right? Design the process for the second one. Actually, both of them can use this process to fabricate. Okay. So now you can see the center one is the anchor, okay, and this one is a rotor. So a rotor with the dimple on the bottom. So when the rotor is released from the structure, so it can rotate around this anchor, the center anchor, and with a minimal contact with the bottom surface to reduce the friction problem. Okay, so that's the meaning of the dimple. Okay. And on the side, we have 2 layers connect to each other, including the first layer, first poly, second poly. So we have a very thick stator. So the center one, this part is a rotor. The border one, we have a stator. So we can apply electrostatic signal to the border, okay, to the stator, then drive the center rotor to rotate, okay. So actually, up to now, we haven't released that. Okay, so before releasing, we need to deposit electrical connection. So as I mentioned, we define the stator here. So we definitely need to connect the electrical signal to the stator in order to drive the center rotor to rotate around the center anchor. Okay. So then we deposit metal film, including chrominum, very thin chrominum, and also very thick gold layers on the top. Okay. So after we finish all the fabrication process, now we will perform the final steps. So now we have the 8 masks performed already. Okay. Now after that we release the structure by putting the whole chip inside hydrofluoric acid solution, and then we take out all the superficial layers, the PSG, the silicon oxide layers. So then we can release the center rotor structures. So when the rotor structure descends onto the surface, you can see that it's only a small contact area from the dimple to the bottom electrode surface. Okay. So actually, we apply only very short time of the HF etching, because if you have a long time etching, the electrode layer, the gold and the chromium layer, can be taken away. The gold is okay to resist the HF etching. However, the bottom chromium, the addition layer, is not a good, resistance material to HF. So the bottom chromium can be etched away. So that's why we need to try to keep the final releasing process as short as possible. Don't make it like 10 minutes or even 30 minutes. So everything will be gone, okay? So it's important to keep it in short time. So that's why we need to use a very good superficial layer. For example, like phosphorus silicon oxide layer. Kind of material can be actually in very short time, very quickly. For 1 micron, like a couple minutes can be easily taken away. Okay, so this is the final structure of the device. So it looks very familiar, right? As we mentioned about the surface micromachining process, we already have this structure and devices showing once. So you might be very familiar with this structure already. Okay. So the similar fabrication process is only an example. We can use this to fabricate the electrostatic motor, but not only for electrostatic motor. We also can use this to fabricate a lot of different kind of things. Okay, for example, we will show one like a micrometer case later on by Sandia Lab. Okay, and before that we will have some overview of the whole fabrication process again. So as similar to the CMOS process, now I put all different layers here as a first column. Then the action they are doing, I put into the second and the third column. So for the first one, the poly zero, we are doing deposition of polysilicon, for example. And the first oxide actually is not doing deposition, it's doing contact, and that means we punch the hole. We're doing RE etching process to make the hole when we apply this mask. So those are masking process. Poly zero, first oxide, dimple, remember. So dimple actually we also punch a small hole on the first oxide. But when we apply first oxide, this command, this masking command, actually we want to connect the poly 1 to poly 0. That means we take out all the material of the first secure layer. Dimple only halfway, okay? Not all the way to the bottom. So there's no connection. Dimple is only make extra structures under the first polysilicon layer. That's the purpose. Then the first polysilicon, we deposit polysilicon layers 2 micron, and then we do thin oxide. So now we need to understand after the first polysilicon, and then we deposit the second oxide. We call it thin oxide. We deposit the second oxide, and the second oxide deposits all over the surface. So there's no command, masking command here. But on the after the second oxide deposition, we have 2 commands. One is the thin oxide, the other is thick oxide. These 2 are the etching of the superficial layer for the thin oxide etching onto the second oxide layer. So if you want to make a contact between the poly 1 to poly 2, poly 2 to poly 1, so we're using the thin oxide command. So you want to make the poly 2 contact to the bottom surface, poly 0. So we will use the thick oxide command as we mentioned. Okay, so remember, after the second oxide layer deposition, we have 2 choices. One is the thin oxide, the other one is the thick oxide. Okay, depends on the poly 2 need to be contact to poly 1 or to poly 0. Okay, either one. So after the contact, we deposit the second poly. So the second poly need to be patterned as well. So the next mask will be the second poly to define the structure of second polysilicon. Then the final structure of the metal, we define the metal structure. So in total, we have 8 masking layers here. 1, 2, 3, 4, 5, 6, 8, 9. Sorry, 9 layers because we forgot the dimple one. Okay, so totally 9 masking layers here. Okay, 1, 2, 3, 4, 5, 6, 8, 9. Yes, 9 layers. Okay, including the metal layer. 9 masking layers. So the masking means the definition of the structure. Okay, define the structure, the pattern. Okay. So those are the things we mentioned in the fabrication process. So in addition to those 9 masking layers, we have another extra two things, which is not mentioned earlier. So one is we call the hole 1, and the other is hole 2. Hole 1 and hole 2 means we want to punch a small hole onto the poly 1 or poly 2. Okay, so the purpose for that is actually in the current electrostatic motor, you won't have this kind of command because the structure is not large enough. But in the future, if you want to fabricate a very large mirror surface, okay, so when you do the releasing, if you don't have any holes on the surface, you want to do the releasing of the large structure. So the etching need to come from the edge. So it takes a long time to etch it until to the center. For example, you have like a 1 millimeter size mirror. It's a plate sitting on the surface. You want to release that structure. So you want to etch in from the edge to the center. So the distance is 500 micron away. It's a very long distance. Take a very long time. Remember, we want to do the releasing in 2.5 minutes, right? 2.5 minutes can allow you to etch in through like 100 micron, 200 micron maxima. Cannot go too deep. So you have a very large surface. Definitely you need a longer time. But in that case, your metal layer will be taken away, etched away. So that's a problem. So in order to reduce this kind of risk, so we need to punch a small hole on the surface. So the whole mirror structure is not like a whole flat surface. You can see a lot of small hole over there. So the small hole among them, their specific distance around like 100, depends on the design. For the hole 1 or hole 2, there's a fixed distance around like I think the distance with releasing hole is 30 micron. That's from the design rule, actually 30 micron. But usually we won't use this kind of high density holes. Maybe we can use like 100 micron, 200 micron, depends on your needs. So the purpose for hole 1 and hole 2, because poly 1 and poly 2 have different thickness, hole 1 and hole 2 actually is RE etching on these two surfaces to make a small hole. So in this case, we can have a lot of releasing hole. So the etchant can go from this hole into the button. So when they take out the material from the button, you won't go to a long distance. Okay, so this kind of purpose. Maybe I can show you one example of hole 1 and hole 2. Let's see. Let's come to here. Okay, yeah. So this is a micro mirror from the Sandia lab. Okay. So this mirror has been pushed up and to a certain kind of angle. So you can see a lot of small holes here on the top surface, right? Those holes are for releasing purpose because this area is a huge area. So when they're already still sitting on the surface, you take a long distance from the edge, etching through the bottom material until they come to the center. So in this case, they take a long time, maybe 10 minutes, maybe 30 minutes. It's too long. Okay, so that's why we need to punch some small hole to allow the etchant going to the bottom of the surface for releasing purpose. Okay, is it clear? So those holes is exactly the things we mentioned. When you have a large surface area you want to release, okay, so you want to release them at a short time. So you need to consider to put some small holes over here. So we have 2 different types of hole, hole 1 and hole 2. Hole 1 is for polysilicon 1, 2 micron. Hole 2 is for polysilicon 2, 1.5 micron. I mean the thickness of the hole, okay? So there's a purpose for that. So let's finish this before we take a rest, okay? So now we have all these 11, okay, masking possibility here. So when you go to the design, go to the software, also the interface of the software, you still can, similar to your CMOS design, okay? But currently, we change the material and change the masking process differently. So we will use different technology for your design. So now you will change your technology resource. Remember in the setup, there's a technology selection. So the technology now need to change from the CMOS process into the MUMPS process. After you do that, all the template will be changed, okay, into the current setup here. Okay, so now you can use that for your design. Okay. So remember, every time when you want to change a different fabrication process, you need to change the technology file inside your software. Okay. So you can accommodate it into different, companies' design rule. For example, if you want to use TSMC's design, you also can use TSMC's design design file, the technology file, import into your software. So the TSMC's design rule will be correctly applied into your design. Okay, similar things. Okay, some things you need to remember is the polysilicon the sheet resistance for different polysilicon is poly 0 is 20, and the poly 1 is a little bit lower, 10, poly 2 14. So poly 0 is okay for connection and for electrical connection, but however you need to remember the resistance is pretty high. So don't do long distance connection of the signal. And the metal 0.05 ohm per square, so it's pretty low. So it's okay by using the metal layer to connect a long distance signal. Okay, it's better to use in the metal, the gold layer. So it's much lower than the polysilicon for the resistivity. And some easy design rule you can follow is a line and the spacer sizes need to be larger than 3 micron, and the overlap and the border need to be larger than 5 micron. The holes releasing holes distance around like 30 micron, but sometimes we can increase a little bit to 100 micron, but if you put it like 200, 300 micron, it's too far away actually. Usually we don't leave them larger than 100 micron. Okay, you can consider that. So other more detailed design rule, you can go to the web to check the newest information from them. Okay. Okay, so we stop here and take a rest, and we come back to the lecture later. Thank you.